17. How about next? I make a whiteboard. Come on. Yeah. And yeah, think about 17. So first, you just go to find this. All right. Arcsine 3/4. Yeah, maybe it's not a spatial angle. Suppose it's not a spatial angle. All right.
Yeah.
You just call it theta. Theta arc sine. All right. Then we want to solve for cosine theta. All right.
Yeah.
Yeah. So first, tell me theta is in which interval?
It's
That means that arcsine should in which interval? And theta must greater than or equal to what? But less than what? Do you have this idea?
greater than or equal to 0. Wait,
Yeah.
and
Yeah, as we mentioned, we will always include 0 to half pi, right? What should we go from negative to half pi, or we go from 0 to pi? Normally, we have this kind of two choice, right? So for here, it's which choice? Okay, so let me tell you, it's for arcsine. Yeah, okay, let's draw sine. Sine is like this, right? Like this. In order to it's 1 to 1, you cannot make use of this 0 to pi. Yeah, impossible. You can only use this. From negative half pi to half pi, right? Yeah, so let me. Anyway, theta should among negative half pi to half pi. But as here, this is 3/4, means it's positive. So theta should just, yeah, we can say it's greater than 0, but less than half pi, right? Means it's an acute angle. If so, of course, cosine theta greater than 0, right? Now we can use right triangle. Yeah. This is theta. If here, this is right triangle. So if the hypotenuse is 4, then the operator is 3. Then we can get the adjacent is 7 square root, right? Then we get cosine theta, which means cosine arc sine 3 equal to 7 radical over 4. Then we're done. Yeah, even we can go to check answer for chapter 9 test 11. Let me copy. I'm sorry. Let me set this. Chapter 9 test. Yeah, 11. Yeah, so this answer is correct. Now, 15. Simplify the following expression. Assume that x greater than 1. Arctangent. So, if we have the code 15. Yeah, if we have this kind of arctangent x, yeah, of course, we also call its tangent here negative 1x, right? Now, let's have some knowledge about it. What's the domain for this? What's the range for this?
Domain
Domains or real numbers. In range is negative pi over 2 to positive pi over 2.
Yeah. How about Ray write the domain? Leo write the range. Arctangent. So suppose the range is not correct. The range should mean some angle, right? Means angle. Yeah, so let's talk about it. For tangent, it's like this. So the asymptote is negative half pi to half pi. And of course, it's repeat, right? It's periodical. So after each pi, you get the same thing. After each pi, you get same thing, right? So which interval will choose for inverse of arc for tangent? Yeah, as we mentioned, we always include 0 to pi, right? Then we have two choices. One is we choose this. Another is we choose this. Then to make it convenient, of course, we choose this. That being said, from negative half pi to half pi. Yeah, if so, Leo, could you provide the range for arctangent, function of arctangent?
So arctangent would look like
So its range is the domain of the tangent, but just this interval, right? Yeah, that means that it's negative pi over 2 and 2 pi over 2 exclusive, right?
pi. Okay.
Yeah. Now let's say for arctangent, this is its input. It's greater than 0, right? So this is positive. Then for positive, suppose this angle is within. Oh, let me use a different color. I mean, it should within here, right? That means that the angle should acute greater than 0, but less than half pi. Anyway, you can take a screenshot for this first. I need a space. So I will erase most of this. You done?
Yeah.
Okay, so let me erase some of the. Okay, so now let me draw arc tangent. Suppose it's like this and this. So the iscenter is negative half pi to half pi. Yeah, so this is x, this is arc tangent x. Right? Yeah, as we mentioned, as here, square root of x squared minus 1 is positive. So suppose arctangent, the function value is an angle between 0 to half pi. Then secant like 1 over cosine. Anyway, let's call this angle theta equal to arctangent x squared minus 1. Then it should greater than 0, but less than half pi. Then secant theta is what we want. It's equal to 1 over cosine theta. All right. Now let's go to find it. Yeah, as it's an acute angle, we can make use of the right triangle. Yeah, again, if we call this is theta, yeah, let me use different color. Then tangent theta equal to x squared minus 1. Then here is 1, right? Just in this way, it's the tangent theta equal to x squared minus 1 square root. Then the hypotenuse should be just x. Yeah. Yeah, here x is greater than 1. If so, we get cosine theta is cosine theta is 1 over x. Then finally, secant theta equal to x. All right. Yeah, let me circle the final answer. Yeah, you can take a screenshot. Are you done?
Yes.
Yeah.
Okay. So let's go to check answer 15. Yeah, you say just x. Yeah, so each time you go to find the interval for the angle, which will help you decide the sign of trigonometric value. Yeah, anyway, so let's go to next chapter. For chapter 10, I suppose we'll just go through the first two sections. They are also the most important two sections. Okay. Right triangle. Okay, anyway. Yeah, this is something basically we know. Given this side. Yeah, here just make a right triangle, right? Then represent the h by a and theta. Then use the triangle area formula for triangle. Okay, then generally we get this. Either theta is acute or like let me see. How about if it's a right angle? Oh yeah, when it's right angle sine theta just equal to 1, so it's still good, right? So never mind the theta is acute or right or obtuse angle. This formula is always true. A segment of. Okay, so suppose this is now for regular pentagon. Yeah, if this is nth oh, this is just a pentagon. Then it's made of 5 of congruent triangle, right?
Yeah.
Yeah, anyway, you just find the area of one triangle, then multiply 5. You get the area for the regular pentagon. But how to get this? BOA is 72 degree. Then use this formula. Angle of elevation, angle of depression. Yeah, here is the definition. Yeah, could you guys have a try to say if you can do example 9? Let me give you whiteboard. Yeah, could you try example 9? Near here, Ray here. Yeah, go to find the x. Yeah, here just give us idea what means depression angle, right? Or just called depression. Yeah, if you get answer, just write on the screen.
I feel like I did something really wrong, but I'm not too sure.
Oh. Okay. Yeah, I suppose this is correct. It's not very hard. Just this is 35, so this is 35 degree. So we have tangent 35 degree equal to 800 over x. Right?
Yeah.
Why is 1150? Hold. 35.
It's
Yeah, I
supposed
get
to be 55 degrees.
Yeah, here is 35. So yes, 55 is correct. But why get this answer? Using a calculator and round to nearest, 50 feet. Okay, understand.
Oh,
Is there this kind of requirements? No? Yeah, anyway, that means we get wrong result from calculator. Finding the attitude of Satnai. Yeah, here is a little bit of communication. Anyway, let's just say cotangent beta equal to Ca plus S. So Ca is like a variable. Yeah, anyway, we get two, I suppose two variable, let me say. Oh, they just express height by alpha and beta. Okay. Yeah, now let's do some exercise. Let me see. Ooh. Yeah, could you guys choose one from this page? How about Neil? Could you choose one?
43.
43. Okay, let's see. A, B, C, D, E. Okay. The following figure shows regular seven-sided polygon inscribed in a circle of radius 1. Explain why the area of triangle AOB is this. So of course this angle is 2 pi over 7, right? Then per the formula. So A per the formula. Area of triangle equal to half A times B times sine theta. Yeah. Then of course it's both A here AB just means OA OB. They are O1 value of 1. So we get this. Neil, can you do part B? And I need to redo part C. X and Y the area of entire is it's so easy, just the 7 of S of this, right?
Yeah.
C let AN denote the area of a regular n-side polygon in square being using the idea from part A. Yeah. Why is n time? Oh, I know. Show that AN. What means AN? Oh, AN is the area for regular n side. So anyway, it means n of the area of triangle, which is half sine 2 pi over n, right? Then part D. Use the formula from part C and a calculator to complete the following table. Round each result to 8 decimal places. Oh, this is interesting. How about each of you calculate one? Neil, calculate when n equal to 100. Ray, could you calculate when n equal to 10 fourth power? Here, let you round to 8 decimal places.
Oh, I
Yeah.
don't think I did something right, but
So let me do it. If n is 100, Yeah, the formula is here. The formula is here.
Yeah, I did oh wait, I forgot to do that.
Yeah, you need to
Okay.
multiply n. So let me check.
So that's
If n is 100, 2 pi divide 100. Take sign. So this is reading. Don't forget this is reading layer. Then sign. Then time 50. Pi r square. So yeah, so this is correct. Neil, could you calculate again? I suppose you need to divide by 2. Oh, no. Neil is correct. Ray. Suppose it's not 6 something. Maybe you need to divide by 2. So again, let me do
Yeah, I
2
accidentally typed an extra 2.
divide 1, 1, 2, 3, 4. Then take sign. Then time time 5,000. Time 5,000. Yeah, what I can. Oh yeah. Please rewrite it. Oh, can you keep going?
Yeah, I'm just looking at the number.
Three one four 1 5 9 2 4 5 9 2 4
Yep.
5. Yeah, I suppose after you run it here is 5, right?
Okay.
Yeah, so you find this is a way to calculate pi, right? Because when n is approach to infinity, then the n-sided polygon, its area is just approach to the area of this circle. That means it just pi, right? Okay, if you want, you can screenshot. Now let's go to next section. Oh. Law of sine and law of cosine. Have you guys learned this before?
A little bit.
Ray, little bit.
yeah, a little bit, not that much.
You also need a bit. Okay, so who can write? For example, if let me have a whiteboard. Yeah, this is a whiteboard. For example, if we just suppose there is a right triangle, if we call this is A, B, C, then this side we call A in lowercase, right? B, C. And of course, this angle we call angle B, angle A, angle C. Yeah. Then, for example, Neil, can you mention the law of sine? Three. Can you mention law of
It's
cosine?
oh, okay. Do I write it or I just say it?
Mm.
Okay, I'll write it.
Of sine. I remember the law of cosine, but I don't remember the law of sine.
Mm.
So law of cosine is like it's like A over sine A equals to C
Oh,
over
yeah.
sine C
Okay,
or something.
Ray. C square equal to A square plus B square minus 2AB cosine C. Yeah, this is correct. Then can you rewrite it as cosine C equal to what?
Cosine C equals to wait a second.
Yeah. So Neil, you cannot write it, right?
I don't remember the law of sine. I only remember cosine.
Oh, okay. C square minus. Okay, yeah. Then this just means A square plus B square minus C square, right?
Yeah.
Mm. Okay, law of sine. It's not so hard. Last section we learned about the area formula, right? Remember, we have area of triangle equal to, for example, half A times B times which angle? Suppose angle C, right? The angle between them, correct?
Mm-hmm.
Mm. Then similar thing, we have this equal to half A times C times this sine of angle between them, then it's angle B, right? Yeah, so anyway, you just say if here has AB, not have C, then here is angle C. If here is AC, not have angle B, then here is angle B, right?
Mm-hmm.
Then of course you can get half BC sine A, right? Then from this we can get, for example, we make use of this. This means they equal to each other, right? Then after we cancel half A, we get B sine C equal to C sine B. Then cos multiply, we have sine C over C equal to sine B over B. Then of course it's also equal to sine A over A. So this we call law of sine, right? Yeah, that means that you can derive it from area formula. Yeah, please screenshot. Are you done?
I'm done.
I'm
Okay.
done.
Yeah, good. Now let's come back. Yeah, here show the area formula, right? Then we can get this. Law of sine. Ambitious case. Yeah, let's do this case. Example 3. It's a tricky case for law of sine, I suppose. Now let's try. Hold on. Yeah, so here just mention it's like this. Yeah, this is I generally draw. This is C, B, C. So anyway, B. Solve the triangle. That being said, you need to find all angles and all lengths, right? Could you have a try? This is 45 degree. So this B is 4, 2 square. C is 8. C, C is 8. Yeah, could you have a try to this? And yeah, this for Neil, this for Ray.
We're finding all the other sides, right?
Yeah.
Okay.
Okay, so you just go to find the angle B. Angle B. You don't need to find all these things to save time. Just find the angle B. Yeah, I should mention this is not true in scale. Yeah, I just general draw it. Yeah, please have a try. Write your process and how you use the formula. Arc sine 3. So Ray, how you know B is 30 degree?
I'm writing my
We want to solve for angle B, right? Determine angle B. Yeah, round angle be to whole degree. Oh, okay, I know what you mean. So you mean B equal to 30 degree, right?
Yes.
Yeah, but if it's exam, maybe you just get a half score. Think about why.
Why?
Because there are two cases. Yeah, you just think about
Oh, I see.
yeah, this is you like make a circle, right? So another case is here. So when you calculate it's 30 degree, actually it's for this case. And oh, let me use different color. One case is here in blue. B is greater than 90 degree. Another is case one. B is 30 degree. You just find one of the case, right? That means that when you get sine B equal to this, there are two possibilities. One is it's B is 30 degree. Another is B is 150. Oh, but it's impossible. It cannot be 150, right?
Yeah, so I get false score.
Oh, yeah.
Yeah.
Okay, then for this example, as there is no chance to be 150 degrees, then you just have one answer. But you have to be careful. In some cases, there are two different cases. Yeah, let's see how the example mentions this. Yeah, when you get this. So actually, there are two cases. But this undefined, right? When B is 150, it's undefined. So there is just one. Next. Yeah, that means that generally when sine B equal to some value, then there may be two cases. B is acute or B is obtuse, right? Okay, now let's say law of cosine. Yeah, they don't mention how they get it. Let me see. They didn't mention. Looking. Yeah, anyway, you need to remember this. Let me see how they. Oh, they use distance formula. Oh, okay. They make a coordinate, right? Coordinate system, then calculate the distance. Anyway, we'll ignore the proof. Then make sure you know how to use the rule. Normally, if we just know one angle, I mean this, we know one angle, but we don't know its opposite side. then you cannot make use the law of sine, right? Then you need to think about the law of cosine. Yeah, anyway. Even here, you don't know any angle. Then you don't have a chance to use the law of sine first. Then think about the law of cosine to at least find the first angle. Now let's do some exercise. How about we do 39? Yeah, now think about it. Oh, come on. My bad. When the sun is viewed from Earth, it subtends an angle of assume that the distance d. Use the law of cosine to compute the diameter d of the sun. Yeah, after this, we'll go to a problem using law of sine. Yeah, this time, how about let Leo do this? Try to write something. Yeah, because just now Ray mentioned the formula for cosine, right? Now we give you a chance to at least to be familiar with the law of cosine and also how to use it. Can you?
I'm thinking.
Mm. Can you write the formula first?
Of the law of cosines.
Yeah.
Something like oh wait, give me a second.
Yeah, let me give you some hint. Good. It's like for general triangle. Yeah, we know this angle. How about we just call it C? Then we know this side A, this side B. Then we want to know C. No. This side C equal to what? Right?
yeah.
Yeah. So we have C square equal to a squared plus b squared minus 2ab cosine c.
Oh, okay.
Then you just use this formula to do this problem. Ray, you can do this yourself and provide your answer like here.
Okay.
Yeah, this is the one for you to provide answer.
Hmm. I don't know. I feel like that's already wrong. Um,
Yeah,
Wait,
let me
so
keep going right here. So here A equal to B equal to D, distance, right? So we get 2D squared minus 2D squared cosine. Here is 32 over 60. Yeah, but this is D grade, D grade. So finally say here actually means D, right? The diameter. So finally D equal to what? Round to 10,000 miles. Ten thousand. Yeah, anyway, let me say we need to use D grade. No, here should write D square. I already get the answer like unit should be mile. Ray, is this answer you get?
yeah, we're getting there.
Yeah, so here actually we have some scale. D square equal to this, right? Then we have D equal to, here 2D square is uh, like the common factor. Anyway, you can do it like square root D square. Then 2 minus 2 cosine, right? And like this. Then D square take square root. It can just go outside. You mean it's so big? 131 minute. Then 83. Do you mean this? Mile. Ray,
Yeah,
do you
around
mean
there.
this?
Yeah, I forgot to point the thing. Wait, oh yeah. Oh yeah, I missed a square.
Yeah, maybe you forget take square root. Right.
Yeah.
Okay, we'll stop here for this problem. Oh, by the way, if you want, you can take a screenshot. Are you done?
I'm done.
Yeah.
Okay. Then maybe we found one more problem. Let me see. Hmm. Yeah, can we do 23? No, of course I no. Oh, hold. Hmm. Yeah, 15. But maybe we will not do all of them. You will answer in terms of seconds rather than using a calculator. Oh. Yeah, for A, B, C, D, you just need to find one of them. Then you can stop. $15. Yeah, so here for Neo, here for Ray. Which one is easy to get first? Yeah, try to write down your process. Okay, good. So this angle is 20 degree, right? 2 over sine 20 equal to x. So x just means a, right? Okay, fine. So we can get a, we can also get b. Then in this small triangle, we can go to find c and d. Okay, so let's stop here. So we finish all the knowledge for trigonometry. Yeah, let's take a short break first. Let's come back. Are you guys back?
Yeah.
Yep.
Okay. Chapter 11, system of equation. So you say 11.1 is what we are familiar with, right? Two equation, two unknown. Then when we go to section 11.2, 11.3, we'll talk about more unknowns, more equations. Then we have to build a matrix. So this is a class called linear algebra. Anyway, we'll just learn some basic things for this. How to solve equations more than two and more than two variables. Okay, so for this, suppose it's something very basic. Recognize property. Yeah, if two equation, two variable, each equation means a line, right? Because it's a linear equation means a line. Then for two line, there are three different cases. Just intersect at one point. Parallel line means no solution. Or collinear line means infinity many solution. Each point on this line are solution. Yeah, that's what we learned from algebra 1 or algebra 2. Anyway, suppose this is either, right? Addition, subtraction means elimination method. Parabola through given point. Yeah, again, build two equations. Using SERP 9 and demand. Mixture problem. Yeah, maybe we can go through this this word problem. That means how to build the equation from this information. Yeah. Can you guys have a try? From information here, build your system equation. Near here, Ray. I'll give you 3 minutes. Yeah, when we reach 1924, then I will try to show you guys. Before this, you can try to provide something. Yeah, we'll take this as the exercise for this 6. Okay, to save time, let's do it together. You just suppose for this, for the 20% is you use X milliliter. For this, you use Y milliliter, right? Then add them together, it should be the total 100 milliliter, right? This is just a mixture, means before mixing and after mixing. Suppose they have same amount of or same volume of acid, right? So as there is X milliliter of 20% acid, so how much acid here? Suppose it's 0.2 multiply X. Then similar thing is 0.45 times y. Yeah, the total is the volume of acid before mix. Then after mix, how many acid we have? We have 0.3, means 30%, times the total volume, 100. All right. Now let's see how to solve this. Yeah, so first we can let all this go to whole number. How? By both sides multiply 100. Then we have here get 20x plus 45y equal to 300. And of course, we can divide by like 5. Then here go to 4, here go to 9. If divided by 5, here go to 60. All right. Yeah, in order to solve it, for first equation, we just both sides multiply 4. So here go to 4x plus 4y equal to 400. Yeah, if we call this is equation 3, this is equation 4. Then we use equation 4 minus equation 3. So we have 4x minus 4x is gone. 9y minus 4y, we have 5y equal to what's here? Oh, hold. Here has something wrong. 3 times 100 is 30. 30 times 100 is 3,000. Then after divided by 5, we get 600. Anyway, then it's 600 minus 400. We get 200. So y equal to 40. X equal to 60 milliliter. All right. Yeah, please screenshot.
I'm done.
Yeah, anyway, that's the answer. Okay, well, this is not new knowledge. We'll just skip it. Now go to 11.2. Now we go to 3 equations, 3 variables. For solving system linear in which there are more than 2 unknowns. Ordered triple. Yeah, again, we have x, y, z. If write as coordinates, there is 3 input, right? You can think about it as 3D space, like x, y, z, right? Only you know all these 3 ordered triple, then you can locate a point in the 3D space. Then you can keep going. 2 unknowns, 3 unknowns, 4 unknowns, and keep going. Yeah, here means for the 3 unknowns, if you know one of them, you take into the equation. it can simplify to two equation, two unknowns, right? A system with no solution. The elementary operation using also the Gaussian elimination, just like what we do. You eliminate one variable, then you just have two unknown, two equation left. Then you can keep going, eliminate one more till there is one equation, one unknowns. That means that even it's two equation, two unknowns, we also use this kind of elimination method, right? So with no solution. Yeah, let's try to do one exercise. We don't want it's very complicated, which will be too time consuming. How about let's take one? Yeah, let me find one. Find all solution of each system. Yeah, how about let's just do problem 11. I put it in the yeah, let's do this. Yeah, could you guys have a try? Eliminate one variable. Let me for Ray eliminate z. Yeah, I write z here means you eliminate z. For Neil, you eliminate y. Yeah, I write y here. Then you mean you need to eliminate y. Then to say what you can get. Yeah, please don't just think. Write down something.
I'm writing on paper because it's easier to write than on the computer.
Oh, okay. Oh, you already get the answer?
Okay, that's what I got.
Okay, cool. Then z equal to 2x minus y plus 1. 2x Yeah, it's correct. Okay, good job. This is correct. Then we'll go to next. Matrix. So I suppose this is your first time meet with matrix, right?
Yeah. Yeah, particular number considered code its entry. We can be a good deal of bookkeeping involved in using. We can organize our work efficiently by using a matrix, which is simply a rectangular array of numbers enclosed in parentheses or brackets. Here are some examples. Okay, yeah, then we call row. How many row? Row 1 to row 3. How many column? The number of row not necessary to be the same as the number of column. They can be different. Then for matrix, when we say it's 3 by 2, it means 3 row, 2 column. 3 row. So this is 2 row, 3 column, right? We write as its size or dimension is 2 times 3. Yeah, that's some basic definition for matrix. Then we call this is a coefficient matrix. Augmented matrix. Add one more column. Then we can write this in matrix form, right? Using the augmented matrix. Some elementary operation. Yeah, you just think, for example, each row just represent an linear equation, right? So this found with some linear equations property. Multiple both sides of an equation by a non-zero constant. Interchange two equations. To one equation, add a multiple of another equation. Corresponding the operation for. Oh yeah, means they matched. Yeah, here show something. First row time 10. Row 2 and row 3
interchange. Then first row multiply -4, add to second row, right? So they are a correct operation. Means this will not change the solution. Yeah, normally we call this is row operation. Yeah, row operation mentioned here. Row operation, which will not change the solution. This will help us to simplify the matrix. Or we call it elimination, right? For example, for the last equation, it means AD9Z. Yeah, like here, equal to this. Only Z left. We already eliminated X and Y. So from this, we can get Z. Then go back to find X and Y. Equality of matrix. They have same size, and the corresponding entry are equal. Then we call them equality of matrix, or equal matrix. Then matrix addition, just the corresponding entries add to each other, right? Scalar multiplication. If matrix multiply a scalar, which just means multiply a number, right? Then just use this number multiply each entry. Then we have this kind of property. It matches with our common sense, right? Definition. The inner product of a row vector and a column vector. Yeah, for this, I suppose you can forget it. We don't need to go. We don't want to go too deep. Yeah, here show how to do product of two matrices. They have some requirements to it, to its size, in order they can have product. Normally, it means the number of column should equal to the number of row for another matrix. Only way each has corresponding one to do multiply, right? 1 multiplied to 5, 2 multiplied to 7. Yeah, it's like the. Then we have to also grasp here. They need to have same size. Here means number of column is the same as the number of rows for this second matrix. Only this way they can do an inner product. Okay, we are trying not to go too deep. But if you are interested, you can have some self-study here. How they net two matrices multiply, then get product. Product also a matrix. So suppose you need to decide each entry, right? Okay. Yeah, don't go too deep. Then we'll, let's say, inverse determine. Yeah, we may just go to here. Okay, inverse. What means inverse of a square matrix? Yeah, when two matrices, its a product is a unit matrix, then we say they are inverse of another. Yeah, it's like our reciprocal, right? When A over B multiply B over A equal to 1. Then we'll say this is the inverse of this. Anyway, it's the similar concept like reciprocal. But here it's the matrix. And also what means unit matrix? It means for this diagonal from top left to right bottom, bottom right. Right. Each entry in the diagonal is 1. All other entries are 0. Then we call it unit matrix. Find the matrix of inverse. Yeah, you just suppose it's A, B, C, D, then go back to solve A, B, C, D. Then you find, let's say, code. Anyway, if A is 1, 2, 3, 4, then inverse of A is this. Because only this multiply this, you get a unit matrix. 2 by 2 unit matrix. Then they also show you a method how to do it. Using matrix algebra to solve a system. AXB. Find A inverse of A. Then both sides multiply inverse of A. This side go to unit matrix. Another side is inverse of A multiply B. Then it will be the solution. So the question is how to find the inverse of the matrix, right? I suppose they'll show you a way. Let me see where they show you. Maybe it's next section. Table encoding a message by means of using message checker.
Okay, let's forget this. They still not show you how to, let me say, determinant and Kramer rule. Yeah, let's go back a little bit. I suppose they show how to find the inverse of the matrix. Let me see. We go too fast. Inverse of. Yeah, I don't find it, but suppose, as I know, for example, for matrix A, then you have a unit matrix here. You do the operation to let A go to a unit matrix, then here go to B. Then B will be inverse of A. This is the rule. But I don't find it. Maybe in next section. I'm not sure. Hold. Okay, anyway, let's go here. 11.5. Determinant. Nth order determinant. For 2 times 2, determinant equal to this. Just AD minus BC. Only this not equal to 0, then it has solution. For this, for AX equal to B. Yeah, of course, we solve for X. And also only this not be 0. Suppose it has inverse matrix. So that's the reason we call this is a determinant. It will help us determine something. Compute a minor or a cofactor. Minor 4. Yeah, okay, here mention something. The value of nth order determinant when n greater than 2 is defined in terms of certain determinant of order n minus 1. A third order determinant is defined in terms of second order. Yeah, it means you cancel this row and this column. Then there is just a minor matrix left, right? Then find its determinant. Anyway, I suppose there is some formula. To find the determinant for 3 by 3 matrix. So let's say minor and cofactor. Yeah, if it's 3 by 3 matrix, it's the determinant decided by this. By the way, for this, it's like absolute value. Then for here, it just means determinant, right? expanding the determinant on its first row. Yeah, you don't really need to worry about how to find the determinant. Because if you read here carefully, of course, you can know how to do. But we want to focus on why we need this determinant. It will help us to judge if there is one solution or it's no solution or many solutions. Many infinity solutions. So we need to go to, let me say, dx equal to, yeah, Cramer's rule. Okay, it's here. For example, we want to solve this system equation. It's three equations, three unknowns, right? It's already kind of complicated. Then Cramer's rule tell us this means D is a determinant for the coefficient matrix, right? Dx means you use this. Replace the column for x, right? Anyway, it's called dx. Then similar thing for dy, dz. Then you'll find the answer will be, for x, it will be dx over d. Yeah, don't forget the determinant. Each determinant just means a value or a number. So the ratio of this must be a number, right? Then by this way, you can get the answer. Yeah, so this is the basic thing you need to grasp. Yeah, you can take a screenshot. Are you done?
I'm done.
Okay.
I'm done.
Yeah, then let's talk a little bit about how to get a determinant. Here mention when the one. Yeah, here show how to find the, let me see. No, this is just an example, not the general rule. Property summary theory. Definition of what? Minor and cofactor. Yeah, they don't mention it very clearly. And they show in like example. So let me say. They just mean do row expanding. So how about let me show you if a matrix, yeah, is A, B, C, D, E, F, G, H, I. Right, this is a matrix. In order to find its determinant, yeah, I am not ready. Then you do it like this. So we'll expand by the row, for example, by the first row. So for this, you cancel this, get a minor. So here is the minor. Then it's A multiply, let me write the negative one in the front, negative one.
So A is first row, first column. So it's like this. This will decide its sign, then time A, then time this minor. Means E, F, H, I, right? We already have the determinant for 2 times 2 matrix. Then when we go to B, plus -1. For B, B is first row, but second column. Then B. For B, let me use purple. So for B, you need to cancel this and this. So what left is A, F, G, I, right? Then finally for C, what color I can use? How about black? Yeah, for C plus -1. So C's place is first row, third column, right? Then C multiply. For C, you just cancel. The row is located and the column is located. So just left D, E, G, H. Yeah, this is what it means. In order to get determinant for 3 by 3 matrix. Yeah, you can screenshot this. Are you done?
Yeah.
Okay.
Yep.
Yeah, so this is why the exponent. Oh, hold. What's wrong? Yeah, they mention here. -1, I row, ith row, jth column, right? Then minor of B. Yeah, you can check with this example to understand it. Then, as I mentioned, you need to know how to use it to do this. Yeah, Cramer's rule here. Then follow this example. Then know how to do it. Okay, that's all we'll learn from chapter 11. Then for your homework, you can go to chapter 11 test. Yeah, just take something you can do. Don't go too deeply. Okay, that's all for today. I'll see you next week. We just have one more week before we close all the courses for this class. Okay, see you next. Thank you.
Bye.
Bye.
Bye. Thank
Bye
you.
bye.
Yeah, I know it's too hard, too challenging.